So we've been discussing logarithms for a few days now, and it's time for us to introduce the natural logarithm, ln. Now, at some point in time, like I said, they just decided that it was easier to use words like logarithm than to use symbols. And darn it, they did it again with ln. And it makes it seem like ln is something different, like, it doesn't, it has its own set of rules, but no, it actually doesn't. ln is simply a logarithm, but it was so common, such a common logarithm, that mathematicians decided to give it its own, what they call a symbol, ln. But ln literally stands for log of natural base. Last unit, we were talking about exponentials, and we had something called the natural base e. Well, e is called the natural base. So ln, which stands for log of natural base, is literally log base e. So instead of writing log base e over and over and over again, mathematicians eventually just got lazy and said ln, log of natural. Now you'll notice, for some reason, I use cursive L's when I write ln. I don't know why. I just always have. So I will always do. I'll just continue to do that. No, there's nothing wrong with it. You just might notice that. In case you noticed it. So there you go. So from now on, when you see ln, your job is to think, oh, that just means log base e. They are exactly the same thing. Again, log of natural. That's where ln comes from. But it is literally log base e. So as soon as you realize that ln is just log base e, you understand why exponential base e and natural logarithm are inverse operations. E cancels ln, ln cancels e, because log base e cancels exponential base e. Exponential base e cancels log base e. ln is log base e. It's just a faster way of writing it. What that means is that the natural logarithm follows exactly the same rules as a standard logarithm. It is nothing special about it other than its base. That's the only thing that's special about it, its base. Because e is such a common base, natural log ends up being such a common logarithm. I guess it was just too difficult to write log base e over and over and over and over and over and over. So the thing about e is that it's an irrational number. We know we've already talked about that. It's not a pretty thing. So whenever you have to evaluate e to any power, if it's e to any power other than 0, because everything to 0 is 1. If it's any power other than 0, then you just grab a calculator, okay? So you should be aware that your log test will have a calculator portion and a non-calculator portion. This last little thing that they've said down here is that any number can be written as exponential base e, just like how I was able to say that any number could have been written as exponential base 10. Remember we did that with logs in the common log? And I was like, hey, let's write 2 as a power of 10. And we said, okay, 2 is equal to 10 raised to the log of 2. We could do the same thing with e's and ln's. It's the same trick. But we won't. But we could. We won't. Oh, no, yeah, we will. Use your calculator, write the following in the form e to the k, where k is correct to 4 decimal places. Okay. Well, e and ln are inverse operations. So if I said e raised to the ln of 50, this is 50, because normally the e and the ln would cancel. And then what we would do is we would grab a handy-dandy calculator, and we would ask it, what is the ln of 50? And it'll tell you, now you're going to pretend to know these numbers, 3.912. There you go. So e raised to the 3.912, that's pretty close to 50. It's pretty close to 50. So that one over there, if you understand exponential rules and things like that, looks to me like I would just need to subtract 1, 2, 3, 4 from this. So it should be 3.912 minus 4. or minus 5? 6? What is it? Ah, crap. Now I'm having trouble doing the math in my head. But anyway, you would say e to the ln of 0.005 because e and ln would cancel, right? Then you grab handy dandy calculator and you ask it what is the ln of 0.005, and you get negative 5 and change. Negative 5.2983. They said 4 decimal places. You know on your test everything is 3 significant figures, 3 sig figs. Or more. More sig figs is fine. Less sig figs is a no-no. So why? Why is that the answer? Did I type it wrong? Huh? Is that an iPhone? No? Okay. So how would we have gotten that answer? Where'd that answer come? It says 4 decimals, right? Why don't I have 4th decimal and it's 3.912? Was the 4th decimal 0? Oh, okay, well, that's why. All right, cool. All right, I thought my notes were ridiculously wrong. Anyway, how would I get from 3.912 to negative 5.298? Looks to me like you could subtract. Would that work? I'm trying to see if there was an easy way to know that's what the answer was. No, I'm struggling. I don't know. Well, whatever. Maybe I shouldn't even bother. You would have used the calculator anyway, right? There you go. I'll stop trying to big brain my way to it. We'll just say, what? There should be, because this, if you, 1, 2, 3, 4, because if you multiply this by 10 to the 4th, oh, that's why I'm struggling. I was using log base 10 rules. Okay, I'll be all right. I was trying to use log base 10 rules in my head.
That seems like just more effort to do that.
I was just trying to big brain. What's up? No, all we're doing is taking the ln of 0.005.
I know. But like, what are you doing?
I was trying to guess, and guess isn't the right word. I was trying to predict the exponent without using the calculator. Remember how I did that with the log base 10 stuff, and I was like, it just makes sense because I just subtracted a certain power of 10.
Yeah.
I was trying to do the same thing here, but I forgot these are powers of e, not 10.
2.7.
Yeah. I forgot that I was doing base e. I was trying to do powers of 10.
I see.
Which doesn't make any sense when you're talking about natural bases. Natural bases are calculator land. So it says find x if the ln of x is 2.17. That just means I need to isolate x. I have to cancel log base e, because that's what ln is. How do I cancel log base e? Yeah, exponential base e. That is log base e. So you just exponential base e both sides, and what you get is that x is e to the 2.17. And you just grab your calculator, because who knows what that number is? 8.758. There you go. Yep. Boom. We're not overthinking this. E's are calculator land. Again, over there for part B, I got to cancel log base e. That's what ln is. I need to cancel ln. So I use exponential base e on both sides. So x is e raised to the negative 0.384. Grab a handy dandy calculator, because good luck knowing that number. I don't know why it's handy dandy calculator. Oh, you know why? I think it's from Blue's Clues, handy dandy notebook. I think that's where I got that from. 0.681. I've been saying handy dandy calculator for years and didn't know why. I bet that's why. I bet that's why I do it, because my kids used to watch a lot of Blue's Clues. My kids watched a lot of it. So you know you remember those log rules that we talked about the other day? The laws of logarithms? The whole, if you have a product inside the argument of a log, that's the addition of 2 logs. If you have a quotient inside the argument of a log, that's the difference of 2 logs. And if you have an exponent in the argument, you can just move that to the front. Those rules are exactly the same thing for ln's. Why? Because ln is log base e. It's not special in any way other than its symbol. It has to follow all exactly the same rules. So there's the exact same 3 rules, just written with ln instead of log. But they follow the same rules because ln is log. It's log base e. So it says use the laws of logarithms to write the following as a single logarithm. It's the exact same directions, only we have ln's this time. So for part A, it would just be, oh look, the addition of 2 logarithms that have the same base, because those are both technically log base e, they do have the same base. This would be the ln of 5 times 3, which is the ln of 15. Please don't overthink it. Part B, oh look, the subtraction of 2 logarithms with the same base, log base e. So that's just going to be a quotient in the argument, the ln of 24 over 8, which is the ln of 3. I think the reason why I use a script L is that way it doesn't look like an I. Maybe that's why. Because they use a lowercase l, so it would just look like an I. And the last one. Okay. There's no parentheses, so that minus 1 is not part of the argument. The only way that I can make this work is if that 1 is actually an ln. So what is the only ln that would equal 1? The ln of e. Oh, that's right, because the ln of e is equal to 1 because they cancel each other out. So what I have here is the ln of 5 minus the ln of e. And the reason why they cancel each other out is because the exponent of e here is technically a 1. I mean, that's why it's equal to 1. So when they cancel out, that's why it's equal to 1. So we'll just replace that 1 with an ln of e and go, hey, look, the difference of 2 logarithms of the same base, those are both log base e. That means I'll have a quotient in my argument, the ln of 5 over e. And guess what? That's it. That's as good as that one gets. Because 5 over e is not pretty. That's as good as it gets. These are the exact same examples that we did a couple days ago. Just with ln instead of log. Or was that yesterday? Good gravy, that was just yesterday. It's the exact same examples, it's just every log has been replaced with an ln. Ta-da. Okay, so it says use the laws of logarithms to simplify. All right, well, just like with standard logarithms, this number in the front can be moved to the exponent position for both of these deals. So for part A, we're going to get the ln of 7 squared minus the ln of 2 to the third. And the difference of 2 logarithms is just going to be a fraction in the argument. And since we can't divide 49 by 8 pretty, we'll just leave it like that. Over here, 2, exponent position, and 3, it's missing something. Oh, that's right, it's missing its ln. So why don't we just say that it's 3 times the ln of e? Because the ln of e is 1, right? So 3 ln e is 3. It doesn't do anything because the ln of e is 1. But if I write it this way, I can move this 3 back to the exponent position of the e. So this gets me the ln of 3 squared plus the ln of e cubed. Of course, 3 squared is 9. E cubed is e cubed. Can't do anything with it. And the sum of 2 logarithms with the same base is going to give you a product in the argument. ln's kind of bore me. I don't like them. It's because because the number e, I can't, it's hard to wrap your head around the number e, log base 2, log base 10, log base 3, whatever. You can figure that one out. E, I don't know. The number e is Euler's number, and it was discovered. There's more than one way to find it. One of them involves, what do they call, like nested fractions. It's a number that, so that's one of them. Here, you can find it like this. So 1, so it's like, it's 1 plus 1 divided by 1 plus 1 divided by 1 plus 1 divided by 1 plus 1. And if you dot, dot, dot. And if you carry that out towards infinity, you crash into the number e. That's one way of doing it.
I think it would help, like, everyone's doing, like, when I was learning E, what I think was most confusing for people is the fact that, like, what is it? Describe the number E equals 2.71.
Okay. 2.71, isn't it 2.718? Yeah, it's like it's 2.718-ish. It's an irrational number, but we did that when we did last unit.
I know, but I already forgot it.
Oh, you already forgot it? Yeah. It's an irrational number, 2.2 and change. But yeah. And if you carry that nested fraction out to infinity like that, you get E. And it's used for compounding continuously, and things like that. Radioactive decay, because it's continuous, stuff like that. Huh?
What are we planning on retaking the test? Is that something we're going to do in class?
No, that was something you guys would be doing on your own time this week. It's already Tuesday. Huh? We'll talk about it.
I would assume you would rather me not take on Friday because we won't be.
We'll figure it out. Hold on. So show that these are true. Remember, show that means you have to start on the left and work your way to the right. So we go, okay, the ln of 1/9, that is the ln of 1 minus the ln of 9. Ln of 1. Well, remember, ln is a logarithm. And it doesn't matter what the base is, if the argument of a logarithm is 1, that logarithm automatically has a value of 0. The reason why is because what it says, so this is like thoughts that are up in the air. It says this, log base e of 1, which asks, what power of e would give me a 1? 0. E to the 0 would be 1. So that is why you could say 0 minus, and this ln could be the ln of 3 squared, and then you can move the 2 to the front. That was one way of doing it. And the other way of doing it that we talked about yesterday is I could have just called that ln of 9 to the negative 1, or the ln of 3 to the negative 2, whatever. Either way, you're still going to get here. Now for part B, we are going to cheat a little bit and look ahead and see that there's a minus there. And a minus would only occur if we had used some kind of division in the argument. And I see there's a minus ln 2. So clearly I was dividing by 2 in the argument. And you go, oh, okay. So then what I could say is the ln of 500 is the same thing as saying the ln of 1,000 over 2, which is the ln of 1,000 minus the ln of 2. And you would grab your calculator. And the ln of 1,000 is, hey, 6.9078. Done. Just like that. LNs are kind of boring. I don't really enjoy doing these. And then lastly, we're going to condense these logarithms and then cancel them. You can't cancel a logarithm until it's been condensed. So if you have pluses and minuses between logs and stuff, don't try to cancel your logs. In part A, we see that 3 does not have a logarithm. So we can say that it's 3 times 1, which is the same as saying ln of e. And now it has a logarithm. And what I'd like to do is take the 2 and make it an exponent of this c. I'm going to take a 3 and make it an exponent of this e. And hey, look, the sum of two logs with the same base. That's going to create a product in my argument. The ln of c squared e cubed. And now that everything is fully condensed, and I have nothing but a single log on the left and a single log on the right, I can cancel both of those logarithms with a matching exponential base, which would be exponential base e, leaving me a equals c squared e cubed. Same process on the right. That 2 doesn't have a log, it needs one. So you strap an ln of e next to it. And once you've done that, you can move these coefficients back to the exponent position. The ln of m, what's that? M is drunk. The ln of m, come on, catch up. You can do it. Come on. Hello. There we go. The ln of m equals the ln of a cubed minus the ln of e squared. Difference of two logs gives you a quotient in the argument. It's always top minus bottom. And then lastly, since there's a single log on the left and a single log on the right, cancel those logs with a matching base. There you go, exponential base e, canceling log base e, finito. Boom. Mic drop.
Good job.
I do what I can.